Hello everyone, and welcome to Engineering for Social Change. My name is Dylan Hazelwood, and I'm the Assistant Director of the Center for Engineering Concepts Development, or CECD for short. I helped develop this course and have been involved in offering it from its early beginnings back in 2014, when our director, Professor Davinder Anand, had the unusual idea of bringing philanthropy and unintended consequences into an engineering course. Let me tell you, at the time, folks took some convincing of this idea. Not only that, but Dr. Anand's Neelam Foundation, named after his son, has provided many thousands of dollars over the years for students to award to nonprofit organizations for great projects to improve people's lives. These have included a breast cancer screening clinic, a drinking water well in Sierra Leone, a teaching garden in Washington, D.C. for elementary school students, school development in Honduras, and much, much more. I'll be visiting you during the semester to talk about electronic waste, but I'm also the course manager, which means I organize speakers, bring in nonprofit organizations, and generally deal with operational issues, like when we should bring in pizza. Let's hope that COVID will retreat enough that we can go back to enjoying that. I want to encourage you to reach out to me if you have any suggestions or issues or concerns as you go through this journey. My email address is very simple, dylan@umd.edu. That's D-Y-L-A-N. Okay, that's enough about me. I'd love to introduce you to Dr. Davinder K. Anand, Professor and Director of CCD and Executive Director of the Neelam Foundation. We've worked together since he hired me way back in 1998 at the exciting dawn of the modern internet. We've written many books together, including Engineering for Social Change, and he has not only been a great supporter and mentor, but also a constant source of new and unusual ideas, not to mention the occasional really terrible joke. He was born in Lahore, India in 1939, which became part of Pakistan less than a decade later. He moved to the US as a teenager with his father, who had a diplomatic appointment. He likes to say that he planned on returning, but ultimately he stayed for his BME, Master's, and Doctor of Science degrees at George Washington University. He worked at the JHU Applied Physics Lab and then finally settled here at UMD, becoming the youngest full professor in the department with a robust research program. He started 2 successful technology consulting companies, served as the department chair from 1991 to 2002, and started CECD in 1998 to work on energetic materials with the Department of Defense, bringing in around $30 million in research funds. His support of faculty, staff, and students in the department and beyond through his chairmanship, his center, and now his foundation is unmatched. I would describe him as one of the kindest and most considerate people I've ever met, despite his frustrating ability to debate circles around me on a regular basis. Without further ado, here is Professor Davinder K. Anand.
Hello, welcome to all of you. Thank you for signing up for this unusual course. I believe you will enjoy this, and only if you get involved and engaged in discussions both in the classroom and with each other, and for once, no equations in sight. I hope that this course and our conversation will create a legitimate subject of study and inquiry at the intersection of engineering, philanthropy, and social change. You will become part of our community where we believe in the idea that all engineering is not just engineering, and I am depending upon you to make sure that this happens because you are the future. This course was originally offered in the spring of 2015 for mechanical engineers, and a year later was opened up for all of engineering. We have had many hundreds of students in total that have signed up for this class, and since it's an elective, I'm both gratified and impressed. This is a good moment for me to introduce the Neelam Foundation, which supports young people using technology to make a positive social impact on society. The foundation has supported this course with prizes and grants and will do so this semester as well. So what is this course all about? Well, it deals with the interplay between engineering and social change and issues that directly and indirectly affect society. Engineering for social change was something I never thought of, and I never met anyone who did. Perhaps you have all thought about it. My areas of interest, however, over the years were in satellite dynamics, in alternate energy, manufacturing system, simulation, and VR, the usual engineering stuff. I taught, researched, and published hundreds of papers and several books in these areas and was reasonably content with my life, my professional life. And then in 2012, I had a personal epiphany, so to speak, and started to question the meaning of what I was doing and how it impacted those that I loved. This was also the time when I established the Neelam Foundation, and that will be awarding prizes and grants in this course. I saw how the world was changing as the internet and other modern communication technologies were instantaneously connecting all of us around the world, making raw and unfiltered information available to almost everyone. The reach of engineering had thus become all-pervasive, and I saw that future engineers must also now become global engineers. My trips overseas clearly showed me how we must move from a focus on developing consumer-driven technological solutions for the world's wealthiest to balancing that with greater development of innovative and low-cost solutions for the needs of the developing world and the poor as well. As the gap widens between the rich and the poor throughout the world, engineers must accept and apply novel approaches to understanding cultural forces. But I also knew that major problems like waste, pollution, the misuse of technology were being created almost in proportion to the progress we were making in engineering and technology. But they were not sexy topics for engineers, and there would be no glory in working on them, so very few did. Somewhere in the back of my mind, though, I recalled that some people had been successful working in these areas. One of my neighbors, it so happened in the other house we lived in, had told me that he was a trash man and was now a millionaire. He had these big trucks going up and down the streets and collecting garbage while he was paying those poor drivers and helpers strong enough to pick up the buckets of valuable garbage at minimum wage. I have traveled around much of the world during my career, and on the one hand, I've seen great splendor, but I also noted how poor people lived on almost nothing. Today, I know that many of the 7.8 billion people of our world, that's a lot of people, are simply unable to keep pace, and many live on less than $2 a day. I also know about globalization and the industrialization of developing countries, but do not have the faintest idea of how these poor people are being helped or employed. Perhaps this is not what engineers think of. My engineering education clearly did not teach me about any of this, and yet I felt like it should have. So here I am at the age of 82, 3 more months I'll be 83, and all this I'm not content. Why? I do not have a precise answer for that. But I do believe that it has to do with the fact that I felt and feel today that what I learned as an engineer was simply incomplete. There was something missing. The engineering you are learning is basic and absolutely necessary and good, but we must, as part of our engineering education, connect to the social fabric of life. Let us pause for a minute and see how technology has impacted our social fabric today. Technology has created significant and far-reaching global social change across a wide variety of areas. Perhaps the most transformative development in the way humans interact, the development and the widespread adoption of modern communication systems has changed the very nature of our society. I remember calling New Delhi and talking to my father in 1962 and paying several dollars for 3 minutes, and that was a lot of money then. Today, a high-definition video call is free. Individuals and groups worldwide are now able to use social media tools for opinion and information sharing. Examples of social networks being used for activism abound, not only by individual citizens, but governments as well. Expressions of individual freedoms, political interference in elections, terrorism, and mayhem have truly laid bare the good, the bad, and the ugly. How can a technology that provides a venue for open and instant communication be both so positive and so negative at the same time? While technology influences culture and human behavioral patterns, culture serves as both a limiting and contributing factor in the adoption of new technologies. Consider the cultures of the Amish people of the United States and the Japanese people, two groups that provide a striking contrast. While many Japanese people still hold on to the traditions that are deeply embedded in their culture, their simultaneous embrace of high technology across their society is far-reaching. For example, the Japanese toilet, of all things, is a marvel of high technology and enhanced functionality in comparison to the Western toilet that we all are used to. Japan celebrates the toilet to such an extent that Toto, a major manufacturer, has a $60 million museum devoted purely to its products. In contrast, the cultural norms of Amish people serves as the anti-catalyst for the adoption of modern technologies. India is another country where culture has played an important role in the implementation of technology. India is today considered to be a newly industrialized country. A desire to preserve culture and tradition has in many ways served as a driving force among Indian engineers and entrepreneurs. An important example is the assimilation of technology in their daily routine. Professionals running short on time in the morning can now download an app on their smartphone that allows them to perform their daily prayer in lieu of physically attending a local temple. In rural India, one is likely to hear that God lives inside the temple and not inside your iPhone, although sometimes I wonder about that myself. In our country, culture pushes back on engineering as seen with the volatile situation surrounding gun ownership, something which I think is quite distressful the way the laws are applied. Now, although smart guns and electronic trigger lock mechanisms have been successfully engineered for more than 2 decades, they have not gained traction with the consumer. Why is that? And it's because our culture and Second Amendment constitutional rights push back on the development of technology. What can an engineer do? For now, there's no answer. There's nothing we can do. Let me pose a few additional questions to all of you. Well, question number 1, are we lonely tonight? I'd say, well, yes, we are. We get an email or a text if you're sick instead of a visit to the hospital. We get an e-card for a birthday or for Christmas and so on. At the office, even when someone is a few doors down, we'd rather send a text or email than call on the phone and talk. We are connected to the whole world virtually. Lord, don't forget the Zoom. And yet we are alone. And I think many of us share a feeling of isolation. I certainly do sometimes. Another question, are we taking care of our planet? No. The answer is no. The wide range of unintended consequences of our unrestrained search for greater technological achievement will in many ways define the future of engineering. While engineers have developed tremendous capability to create products and systems at a scale and speed once unimaginable, we have been careless with the fruits of our labor. When goods become cheaper and widely available, those who could afford them engaged in rampant overconsumption. As a result, our climate and natural environment has been compromised, with the impact of our technologically powered excess even at the furthest reaches of our planet. All right, are we wasteful? And the answer is absolutely. Our volume of trash has risen exponentially over the past 50 years as our modern lifestyle utilizes more and more packaging. It is estimated that around 4 trillion pounds, that's 4 trillion pounds of garbage, is being produced globally each year. Groundwater is often contaminated from poorly constructed landfills, and subsurface smoldering waste fires are another major problem. Unintended waste problems abound from plastics, pesticides, pollution, etc. Electronic waste, or e-waste as we call it, is an unintended consequence of a combination of our engineering prowess and our insatiable desire for faster, newer electronics with more and more features. Our ability to mass produce consumer technology has created a culture of doesn't work, throw it out, buy a new one. And they're cheap. Electronics are also one of our most dangerous forms of waste, as they contain toxic materials such as lead, cadmium, mercury, and even arsenic. It's also our fastest growing type of waste, with estimates in 2021 that 57 million metric tons of e-waste worldwide were created this year. We export our waste to Mexico, Taiwan, China, Pakistan, Thailand, the Dominican Republic, Canada, and Kenya, where small toxic cities are created as people struggle to earn a living from influx of dangerous waste. Are we eating healthy? Don't be ridiculous. Fast and heavy processed food with its excess sugars, fats, and preservatives, coupled with food storage, have made food available anywhere and anytime, and it's cheap. The increased popularity of engineered food has resulted in more than doubling obesity rates among adults in the United States. The average American is now 24 pounds heavier today than in 1960. Similarly, childhood obesity has tripled since 1980. All right, the last question. Who is in charge, and what does the future look like? Now that's a really good question. With so much technology around us, is there more to come? What is the path forward? It's clear that the future will bring significant technological advances in areas of AI, transportation, wireless communication, medicine, food processing, big data, crowdsourcing, climate change, robotics, finance, virtual reality, and many more that are not even known. Some will bring positive change to society, improving and extending our lives through technology, while others, as advanced AI-powered robots, may even challenge our definition of what is a human. It already does, I think, in many situations. The biggest surprise may be the increasing level of manipulation of humanity through technology. Dylan has written a book on the subject, and I've requested he share a copy of his book with all of you, and I think it's going to be complimentary. The second last chapter of our upcoming sequel to the Engineering for Social Change book has a very timely discussion of happiness. This is something that engineers do not pay any attention to, in my opinion, but that is the topic of another lecture. Even with so many technology options to choose from, a large number of students today are not content just playing with equations, apps, and engineering tools in the education sandbox that we have created for them. They want more. They question the very basic assumptions of life, and that's a good thing. These mental ramblings of mine have led to the question I should have asked you at the beginning. What do I want you, our students, to take away from this course? For one, I want you to appreciate that an engineer must understand the true societal impact and consequences of the results of engineering, both intended and unintended, and we mostly forget the unintended. You also must grasp the key concepts presented here. These include the unintended consequences of technology, the connection of engineering to philanthropy, to social entrepreneurship, to innovation, to decision making and social impact. This unique experience will develop a mindset that will enrich your professional career and possibly even your personal life too. The challenge of using these building blocks to create a roadmap for the future, positive social change, is entirely up to you. Remember that you are the future, and some of you are going to be philanthropists. Thank you again, and my best wishes to each of you, and have a good semester.